Settling with power, or SWP, is a dangerous situation for helicopter pilots. It happens when a helicopter descends, even though the engine is producing power. This is not an aerodynamic problem like a stall. Instead, it's a matter of not having enough power to overcome the descent. SWP can happen quickly and unexpectedly, and it is often fatal. Understanding SWP is crucial for all helicopter pilots. It can mean the difference between a safe flight and a tragic accident. Imagine a helicopter hovering in the air. The engine works hard to provide lift and keep the helicopter airborne. Now picture the helicopter starting to descend. To stop this descent, the pilot needs to increase power. This is where the trouble begins. Sometimes the power needed to stop the descent is more than the engine can produce. Even at full power, the helicopter might continue to descend. This is the essence of settling with power. Helicopters behave differently at low speeds. They need more power to stay airborne. As the helicopter slows down, the amount of power required increases rapidly. This is especially true at very low speeds. Think of it like riding a bicycle uphill. The slower you go, the harder you have to pedal. Similarly, a helicopter needs a lot of power to maintain lift at low speeds. This is a critical factor in understanding how SWP can occur. Let's imagine a scenario where a pilot is making a turn at low speed and encounters a tailwind. This situation can quickly become dangerous. The tailwind reduces the helicopter's airspeed, increasing the power required to stay airborne. If the pilot is unaware of the tailwind's effect or doesn't react quickly enough, the helicopter can enter a descent. The combination of low speed, a turn, and a tailwind creates a perfect storm for SWP. Section 5, near the ground, a fatal combination. SWP typically occurs near the ground. This is, well, a recipe for disaster. Why? Because there's little to no altitude to recover. When a helicopter is settling with power close to the ground, the pilot has very little time and space to react. The helicopter might be descending faster than the pilot can recover. In almost all cases, SWP near the ground is fatal. This highlights the importance of recognizing and avoiding the conditions that lead to SWP. Section 6, Causes of SWP. Unraveling the Factors. SWP, or settling with power, is often caused by a combination of factors. These factors can be both human and mechanical, and they often interact in complex ways to create dangerous situations for helicopter pilots. Understanding these factors is crucial for preventing accidents and ensuring safe flight operations. One of the primary contributors to SWP is pilot error. This can occur for a variety of reasons, including lack of experience, poor judgment, or even stress and fatigue. Pilots must be constantly vigilant and aware of their surroundings to avoid making critical mistakes. Specific errors might involve turning into a tailwind, which can reduce the helicopter's lift and make it difficult to maintain altitude. Misjudging altitude is another common mistake, especially when flying close to the ground or in challenging weather conditions. Improper use of the helicopter's controls can also lead to SWP. This includes incorrect maneuvers or failing to adjust the controls appropriately in response to changing flight conditions. Pilots must be thoroughly trained and practiced in using the controls to handle any situation that arises. Mechanical problems are another significant factor that can contribute to SWP. Regular maintenance and thorough pre-flight checks are essential to ensure that all components of the helicopter are functioning correctly. Even a small mechanical issue can escalate into a major problem if not addressed promptly. For instance, a malfunctioning engine might not be able to produce enough power to keep the helicopter aloft. This can be particularly dangerous if it occurs during critical phases of flight, such as takeoff or landing. Environmental factors such as wind shear also play a crucial role in SWP. Wind shear is a sudden change in wind speed or direction, and it can occur at any altitude. It can be especially hazardous when flying at low altitudes or near obstacles. Wind shear can disrupt the airflow around the rotor blades, causing a loss of lift. This can lead to a rapid descent and potentially catastrophic consequences if the pilot is unable to regain control of the helicopter in time. Section 7, Demystifying the difference SWP versus VRS. There's often confusion between settling with power, SWP, and vortex ring state, VRS. While both involve a descending helicopter, they are distinct phenomena. In SWP, the helicopter is using all available engine power, but it's still not enough to stop the descent. VRS, on the other hand, is an aerodynamic state. It occurs when a helicopter descends into its own downwash. This disrupts the airflow through the rotor system, leading to a loss of lift and increased drag. Section 8. Evolving terminology, from confusion to clarity. The terms settling with power and vortex ring state have been used interchangeably in the past. This has often led to a significant amount of confusion among pilots and aviation professionals. Understanding the difference between these terms is crucial for safe helicopter operation. This has led to confusion and misunderstanding. Pilots, especially those new to the field, may find themselves unsure of the exact conditions they are experiencing, which can be dangerous in critical flight situations. Historically, power settling meant running out of power, a situation where the helicopter's engine could no longer provide the necessary lift. This term was used to describe a state where the aircraft was essentially powerless to maintain altitude, while settling with power referred to descending despite having power. This occurs when the helicopter is still generating power, but due to aerodynamic conditions it is unable to maintain altitude and begins to descend. Today the term vortex ring state, VRS, is preferred to describe the aerodynamic phenomenon. VRS occurs when a helicopter descends into its own downwash, creating a turbulent airflow that can lead to a rapid and uncontrolled descent. However, inconsistencies in terminology persist across different regions and training materials. Different aviation authorities and training programs may use varying terms, which can lead to further confusion among pilots who train in different parts of the world. This underscores the importance of clear communication and consistent terminology in aviation safety. Ensuring that all pilots and aviation professionals are on the same page can help prevent accidents and improve overall flight safety. By standardizing the terms used to describe these critical flight conditions, the aviation community can move from confusion to clarity, enhancing the safety and efficiency of helicopter operations worldwide. Section 9. A Safer Future, Vuichard Recovery and Beyond. The Vuichard Recovery VR is a newer technique for recovering from VRS. Developed by Swiss pilot Claude Vuichard, this method has revolutionized the way pilots handle one of the most dangerous situations in helicopter flight. VRS, also known as settling with power, occurs when a helicopter descends into its own downwash, causing a rapid loss of lift. Traditional recovery techniques often result in significant altitude loss, which can be catastrophic, especially at low altitudes. The Vuichard recovery emphasizes a rapid increase in collective to climb power, left pedal input, and right cyclic. This coordinated maneuver allows the helicopter to escape the vortex ring state more efficiently. By increasing the collective, the pilot adds power to the rotor system, generating more lift. The left pedal input counteracts the torque effect, stabilizing the helicopter's yaw. Meanwhile, the right cyclic input tilts the rotor disc, helping the helicopter move laterally out of the downwash. This method has been shown to be more effective than traditional recovery techniques, minimizing altitude loss and improving the chances of a successful recovery. Pilots who have adopted the Vuichard recovery report a significant increase in their confidence and ability to handle VRS situations. The technique's efficiency not only enhances safety, but also reduces the stress and workload on the pilot during an emergency, and improving the chances of a successful recovery. The aviation community has recognized the importance of this technique, leading to its inclusion in many flight training programs worldwide. By standardizing the Vuichard recovery, flight schools ensure that new pilots are equipped with the best tools to handle VRS. The push for standardized terminology, coupled with ongoing research, is crucial for the continued advancement of helicopter safety. Aviation experts are constantly analyzing flight data, conducting simulations, and performing real-world tests to refine recovery techniques. This collaborative effort between pilots, engineers, and researchers aims to develop even more effective methods for dealing with VRS and other in-flight emergencies. And the development of new recovery techniques like VR offers hope for a safer future in helicopter operations. As technology advances, so too does our understanding of helicopter aerodynamics and the factors that contribute to VRS. Innovations in flight control systems, rotor design, and pilot training are all part of a comprehensive approach to improving safety. Offers hope for a safer future in helicopter operations. By By integrating advanced recovery techniques into standard operating procedures, the aviation industry can significantly reduce the risks associated with VRS. This proactive approach not only saves lives but also enhances the overall efficiency and reliability of helicopter operations. By understanding the causes of SWP, recognizing the signs early, and employing appropriate recovery techniques, pilots can mitigate the risks associated with this dangerous phenomenon. Early recognition of VRS symptoms, such as an unexpected descent rate and a loss of control authority, is critical. Pilots must remain vigilant and be prepared to execute the Vuichard recovery or other suitable maneuvers at a moment's notice. And employing appropriate recovery techniques, pilots can mitigate the risks associated with this dangerous phenomenon. Continuous training and practice are essential for maintaining proficiency in these maneuvers. Flight simulators and real-world training exercises provide pilots with the experience they need to react swiftly and effectively during an actual VRS event. Pilots can mitigate the risks associated with this dangerous phenomenon. The commitment to safety and the adoption of advanced recovery techniques like the Vuichard recovery are paving the way for a new era in helicopter aviation. With ongoing research, training, and technological advancements, the future of helicopter operations looks brighter and safer than ever before.